speaking of system protection, I understand there's also new requirements around selective coordination. Chad.
Yeah, so selective coordination in this change in 240.11, it's one of those sleeper changes that I think that didn't get a lot of discussion maybe. Maybe it's one of those things that would be easy for folks to miss. So first, selective coordination is a coordination of the overcurrent devices in the power system so that when you have a fault, the overcurrent device closest to the fault is the one that opens and the only one that opens, leaving power on to the majority of the system. And this is particularly important for critical systems, but obviously it's a design practice that I'm sure, Doug, you look for in general designs as well. So where is it required? Well, we have requirements for elevators in Article 620, and we have requirements for critical operations data centers in 645, and emergency systems, legally required standby systems, and so forth. So there are lots of places across the code where this gets pulled in. Let's look at a graphic that'll help us with understanding how this change in 240.11 will impact specifiers. So if we look at the diagram on the screen, you see to the left your traditional normal power bus, and on the right, your traditional emergency power bus. And the emergency loads are fed through an emergency transfer switch. And the emergency load is designated by the breaker labeled C in your diagram. Well, traditionally, we know that selective coordination is required all the way through that path on the emergency side, all the way to the source. Well, what about on the normal side? Well, selective coordination is required on the normal source, and it's required between that emergency breaker C and the service disconnect service breaker, in this case, breaker A. And sort of we have this big change here now. If we look at the second graphic, that really helps us that all of the breakers at that first level subdivision on the normal side now have to selectively coordinate with the service breaker. So it's not just the feeder, which again, the other articles of the code never really required that to be selectively coordinated, and it's in a strange spot, right? That trigger spot is not with the other requirements for selective coordination. So that normal side is sort of an addition, and Judy, I think that the example I've given here is dealing with emergency systems, but that may be the easy path. The difficult path might be other applications.
Yeah, Chad, that is a big change, and there are a number of applications impacted by this change. It's tempting to just think about buildings that have an emergency power system using a generator, but let's think about a simple commercial building which uses battery backup for egress lighting. Mm-hmm. But that same building might have a bank of elevators, and the requirements in 620.62 are going to trigger selective coordination for the elevator feeders with any supply-side overcurrent protected devices. So this change now expands the requirement to all those first-level feeders at the service equipment. And I think this is a change that's going to be an easy one for specifier to miss because the requirements are located separately from those code requirements which trigger selective coordination. And it's going to likely require some education because it's going to pull in wherever those requirements exist for selective coordination. It's going to require education for owners, developers, and contractors, since this is going to impact things like tenant fit-outs where things are added later and not necessarily with the upfront equipment purchase. Doug, how is this going to impact your work?
This is going to have an impact from an educational standpoint, with specifiers being aware of this change and educating themselves, but also on the contractor side where this requirement hasn't previously been required. So I think it would be our job to kind of bring that to the forefront for the contractors and make it a point so they understand this bidding a job. Enforcement of this code is going to be the key aspect of this requirement. Selective coordination must be performed by a licensed professional engineer or other qualified person. Documentation should be completed, available to the AHJ or the authority having jurisdiction's approval. And it's important to note that these requirements can vary by jurisdiction, and you need to know those up front so you don't get yourself in trouble later. It's important to emphasize that this requirement doesn't directly impact healthcare facility designs, since this code requirement for healthcare facilities requires coordination, which is different from selective coordination.
Yes.
This change will not impact the essential electrical system for healthcare facilities. However, it could affect other buildings on a healthcare campus.
Yeah.
So specifically from a design engineer perspective, what challenges is this code change gonna make for your employees?
Well, coordinating or selective coordination at at higher fault currents can make it very challenging. So I could see this driving equipment size larger, frame size of breakers, causing trip units to be electronic trip, causing more cost to the owner in the upfront case where this hasn't typically been required. So specifiers are going to need to be aware of the types of buildings they're designing to make sure they can differentiate whether coordination or selective coordination is required in this application. During the design stage, engineers do not often know which switchgear manufacturer will be the successful winner. So I would encourage specifiers to partner early with vendors so they can space plan accordingly.
That's great, Doug. Schneider Electric has a team of application engineers in our sales offices and on call who can assist with making those breaker selections. We also have an online selective coordination analysis tool, and in some cases a preliminary coordination study may even be required. ETAP software, which recently became part of the Schneider Electric family, can be used for this type of analysis.